Good afternoon, everyone. I'm really excited to be here. My name is Cass. I'll be your host for the next 40 or so minutes, guiding you through some of the insights we've gained in the area of project generation at Bloomberg recently. So we'll be covering a few topics today. First, we'll be going through a bit of background on myself, Bloomberg, and why we were interested in this topic in the first place. Then we'll move on to talk about Xcode projects in general, how to generate them, and why you might choose to do so. And then we'll talk through the tooling available for you. And lastly, some tips should you choose to go down this path in a project, an existing project. All right, so as I mentioned, my name is Cass. I'm an iOS developer in the mobile platform team at Bloomberg London. This is the lovely view of St. Paul's from our office. It's quite scenic around sunrise. It's one of my favorite views of the city. As for Bloomberg, keep going back. Yeah. As for Bloomberg, you might have heard of Bloomberg News. It has over 2,700 reporters covering various topics in business, finance, technology, and more. You might have also seen Bloomberg TV, a news channel which covers the same topics. However, one of our main products is called the Bloomberg Terminal. It provides a diverse array of financial news, data, and a lot of analytics tools for our users. Those are traders, equity analysts, fund managers, and more. And for all of these services and products, we have companion apps. Today, I'll be focusing on one called Bloomberg Professional, and it's a companion app for the Bloomberg Terminal. And to give you kind of an idea of like the scale of the application, we'll take a small tour. It's available on both iOS and Android, and it used to be available for BlackBerry back a long time ago when that was still popular. Now we're only on iOS and Android. So just a quick walkthrough through our app. The first screen users are presented with is what we call the Today View screen, and it presents personalized information in the form of cards to our users. That is, each of these cards will change each day based on the user's preferences and so on. The first card here is called like Daybreak. It provides a digest of the most important news of the day, and that is different per region. So if you're in the US, you'll get a different card than if you are in Europe. And if you take a look at our menu, you will notice we have a lot more features. In fact, each of these has its own set of flows, has its own service infrastructure as well that powers it. These could be thought of as a separate app, just all lives within our single application. And to help disambiguate, we often refer to them as applets. You might have counted 20 or so icons, but we actually have a lot more because these are just the headline ones, and you can actually navigate to further applets by navigating through others as well. And all of this is being managed and maintained by in a single universal application, and that's over a decade old at this point. So we have quite a fair amount of Objective-C still in our code base. And it's all being managed by over 60 developers in 10 cross-functional teams. That is iOS, Android, and the server-side infrastructure. So we don't have like an iOS team and an Android team, but rather feature teams as well. And to be able to manage an application like this for a team size like ours, we had to adopt modularization. And modularization is a fascinating topic. There was a great talk earlier today, actually, by Tomasz and Christoph about breaking the monolith, which I highly recommend you see on video if you haven't already caught it today. And it has a lot of benefits and some challenges. And one of the main ones we faced was how to manage a large number of projects for these modules. And here by module, by the way, I mean a framework, like an Xcode framework or a target. And being able to manage Xcode projects for all of these frameworks and targets could be quite painful, especially if you have over 50 projects as what we have today, and we're planning on adding a lot more in the not too distant future. So what we've had to do is resort to generating all of these projects, and we'll cover why shortly. But first, let's talk about Xcode projects themselves. And typically you create them using Xcode. You open Xcode, make a new project, and out you get the project, the Xcode proj file. And the Xcode proj file is, as some of you might already know, is not really a file. It's kind of a container for other files. You can right-click on it and show package contents, and you will see those other files. The most important one here is called the project.pbx proj file. And if you open that up in your favorite editor, you will see you can read some of the text there. You can see things like app.delegate.swift, you can see mains.storyboard. In fact, you can scroll through this whole file and you'll see a lot of text, including your build settings and a lot more. For a brand new project that has usually 7 files, the default template from Xcode, you'll get over 340 lines of code in this single file. Some of you might know this file already, or this format of this file. It's a property list, a slightly older property list format known as the OpenStep format. You might be more familiar with the XML form, the one that is used for like your info.plist file. What's really interesting about this file is how closely it resembles the UI in Xcode. And to really illustrate this, let's take an example of adding a new file. So if we add demo.swift, for example, to our project, look at the git diff, and you will notice you get not 1, but 3 new entries in this file. And these are in different sections. The property list is organized into sections here. The first one is called a build file, then you have a file reference, and lastly, a group element. And if you take a look at the Xcode project, you will see that is almost one-to-one. Your build file is what you see in the build phases, for example, the compile sources phase, and then the file, you need a file reference for every file in Xcode, and the group element is what positions it in this file tree view. And this last point is why Xcode can sometimes have a completely different view from what is actually on disk. And this could also be a source of many frustrations. All right. That is a brief intro into Xcode projects and their format. And if you're interested in reading more, I highly recommend you read through this article. It's quite old, but it's still very relevant till today. And it's worth noting that most of the information for the format is not officially documented. It's mostly been reverse engineered, but it's been fairly stable through the years. Yes, like Apple will add a few more attributes from time to time, but the format roughly is the same. All right, project generation, what is it? It's simply taking your source code that lives on your file system or on disk, combining it with a definition file of some form, and then getting a project out of that. And the interesting thing about this is you might have seen this before. This is not a new concept. In fact, if you used Swift Package Manager prior to Xcode 11 and you wanted to edit your Swift package in Xcode, this is exactly what you would do. You would have your package.swift, which would act as your definition file, so to speak, and you'd run this lovely command, Swift package generate Xcode proj, and out you got Xcode proj file. And you'll even notice that in your Swift package, whenever you create one, the Xcode proj file was in your git ignore. So it was a discardable artifact. And what really this empowers you to do is change your source of truth. And what I mean by that, typically in Xcode, as we saw earlier in the PBX proj file, there's a reference to every single file in your source in your file system. So there's a heavy, like a very strong tie between the Xcode proj and all your files on disk. And this makes it a high source of contention. That's why you'll notice a lot of merge conflicts if you're working in a big team or a big project. Everyone editing, adding, moving, or removing files will mean that this file will get modified. So you can imagine there's going to be a lot of traffic on this single file, and hence merge conflicts. However, in the project generation world, that's no longer your source of truth. Now your source of truth is your file system and your definition file. And you might be wondering, but how is swapping one file for another any better? And the reason is just the way it's done. Unlike the project file, where you reference every single file, typically you'll point to like a directory. My sources live in sources, and that's it. Which means if you ever modify, move, or remove files, as long as they're within that folder, you're good. You don't need to touch that file, and that reduces the contention on it. All right, that was a quick overview of project generation, but really, what's the pain points of managing a large project in Xcode? And let's do that in slightly dramatized story form. And the story starts with you as a developer in a team. At this point, the team is really small. You're working on an app. It's called App, originally named. And over time, you add more features. You and your colleagues add features to this application. It grows in size, it grows in features, but this is all good. It's getting more traction, it's becoming more successful, your company gets really interested in investing more in it now, actually, because they see the potential of the application. They can tell that this could do a lot more for them than it already is. So they invest more, and you now have a lot more developers in your team. It's going to be fantastic because that means you're going to have time to add more features, improve the application, optimize it. This is only going to be a good thing. Except this, like the next week, as soon as your team grew, you started hitting merge conflicts more often than usual. You hit them before in the past, but they were like rare. But now you're hitting them pretty much every day, more than once a day. However, you do a bit of research and realize, you know what? Yes, it's annoying, but resolving conflicts isn't that tricky. You can open up your favorite merge tool in Git. In macOS, that would be file merge, and you can see a diff of what's happening. On the left-hand side there in the top left, you will see your changes. On the top right, you will see the other changes. Of course, this will differ based on whether you're merging or rebasing. And then in the bottom here, you'll see what it's resolved to. You can use the lovely shortcut Command D to go to the next conflict, and you will see, you've added feature A, your colleague has added feature B, and you will notice that you need both of them. It's just because the PBX proj is a monolithic file, this is going to happen. So you choose both, you resolve this conflict. As you can see here in the bottom, you've selected both, and you move on to the next one, and you do the same thing. All right. You've resolved this issue, and everyone learns from it. You spread your knowledge about it. Everyone's quite comfortable resolving conflicts. Time goes on, and WWDC happens. And your mind is blown by all the amazing announcements that Apple has made and all the exciting new technologies. But guess who else is really excited about this stuff? Your product team. As the highest priority, you now have to ship an extension for your application because that's where the business is going to go. So you have a look. What do you do? How do you add an extension to your project? File new extension and realize this is a separate target. I need to share some code between my main application and my target. How do I do that? Few options. If it's a small feature, maybe I can just compile the sources twice. It's not a big deal. Or maybe I can make a framework. But let's do this properly. Let's make a separate framework for the shared code. That's how we should do it. So you make your first framework, but you get a really interesting idea. All this time, we've had a lot of contention in one project. What if this is the chance to make another project? Let's put framework or feature A in its separate project alongside its tests. This is going to make development so much quicker, so much faster, being able to develop it in a single project that's detached from the main project. This works really well. You ship your extension, everyone is happy. However, feature B comes along, and you give a tech talk internally at your company. Everyone is sold about having separate projects for their frameworks and features. So everyone is going to give feature B the best shot possible. They're going to do the best practice from day one. It's going to be its own framework and its own project. Except you notice that there's some utility functions you've used in feature A that you would like to use on feature B. What will you do? Why not just pull out yet another framework? And now you have 4 projects in your workspace. And as soon as you're done doing that, a colleague of yours comes along and taps on your shoulder. Hey, sorry to bother you, but it seems that that new framework you added, Common, it's causing problems at runtime. I can't seem to find it. And you take a look and realize, oh, of course, we forgot to embed Common into the main application. And you discovered, yes, every dynamic framework you have in your application needs to be embed. So that is a bit of a nuisance, but you learn from this. You tell all your colleagues, please remember to add or embed dynamic frameworks, even if the main application itself doesn't depend on this particular framework. Just as you finish explaining this, another colleague taps on your shoulder and mentions, my build on CI is failing. I'm getting this error on CI. What seems to be the problem? And you take a look and realize, but it was just building for my other colleague. Well, what seems to be the matter? You take a look at the projects in Xcode. You're trying to compare Common, which is the new one you've added, alongside the application. And you're trying to see what is different. Why is it failing on CI only? And you take a close, hard look and notice, of course, your application has this beta configuration, which you use on CI, and your new framework does not have beta configuration. Unfortunately, this will cause the build to fail if you try and build with the beta configuration. So you remember, now you also let your colleagues know. In addition to embedding the framework in the main application, please make sure that the new framework you add also has the appropriate build configurations. All right, time goes on. And your workspace, so to speak, evolves further and further to have something that looks like this, where you have a lot more frameworks, a lot more projects in your application. This all looks good, and you discover something very, very great. Finally, modularization is paying off for you and your team. You can now have sample applications that exercise the individual features, where you can spin up the features in isolation, test them out in isolation, especially now your team has grown quite significantly, that you have a lot of different groups working on your whole workspace. It's no longer one team, and that means each team can work and own each of these features and be very productive in it. However, nothing is free in this world. As we'll discover, as you have more frameworks, you start noticing your application isn't as snappy as it used to be. This has been improved a lot over the years now, especially with Apple introducing the UILD caching. But you discover that because of all the dynamic frameworks you have, your startup is no longer as snappy. And you do a bit of research, you use this environment variable, the UILD, print statistics, and you do notice a big significant hit because of your dynamic frameworks. So you take a look, and yes, there's quite a few, and you realize, you know what, it's 2019. The only reason we had dynamic frameworks back when we started is because we needed Swift support, and now Swift is supported in static libraries. Let's change everything to static libraries, except you realize that's actually quite a bit of work. You already have a fair amount of projects in your workspace. You need to go to each one of them. There isn't an obvious way of how to switch product types. So imagining you do figure out how to do that, you now have to manually manage headers with static libraries, and then you have to go to every single project and set this environment search path variable. That seems like a lot of work. Is there any shortcuts we can take? Turns out there is. There's something called static frameworks, which is simply the existing framework package or target type, and you just change this build setting, Mako type equals static lib. Or so you think. You think this was a quick win until you build your app, try and install it on a device, and you get code signature failed, and you're like, but why did have to do anything with code signature? And realize, oh, of course, we left all of the frameworks embedded in all of these applications now, and we have a lot more than one application now. We have all these sample applications. We have to go to every single one of them now and update them. The story goes on like this for quite some time, where you're constantly fighting a losing battle against Xcode. In summary, Xcode projects are complicated. But it's not to say that Xcode isn't a great tool. It's a fantastic tool. However, once you hit a certain size, both in your project and your team, you're going to start hitting these issues, and it can get very annoying. Even if you yourself and your team get more familiar with it, you're going to get new colleagues. Colleagues maybe from a different background. Maybe someone working on Android previously wants to help you out on iOS, and them encountering these little nuances could really throw them off. So you have two options. You can actually, before the options, there are a lot of challenges. Some of the ones we've covered and some others which we didn't touch on. And this is not an exhaustive list by any means. So you're faced with two options. One of which is you abandon this modularization thing. It was fun, it was great, but you know what? Let's call it defeat and go back to a monolithic application where we don't face any of these Xcode project issues. Or maybe invest in some alternate tooling. And you have a spectrum of options here. Continue to manually manage your projects, write better documentation, provide better training, or maybe go full out and do alternate build systems, which are great, by the way. They will also not only solve the project's issue, they'll also solve your build time issues, potentially. But the thing is, there's an investment cost for all of these things. Yes, there's an investment cost manually managing your projects, but there's also an investment cost in adopting a whole alternate build system. You'll need a dedicated team who specializes in this to help you and your team migrate to it. And really just like a guesstimate to just put out there is, as your number of modules grow and your team size grows, that's when you should start considering these alternate options. However, if you're somewhere in between, where maybe you want another option, like you're fed up of manually managing projects, but maybe also want to do something about it, This is where project generation comes in. It does need some investment costs, but it's nowhere near as much as alternate build systems. It's the nice halfway house. And the nice thing is, if for whatever reason it doesn't work out, you're generating valid projects. You can just ditch the tool and fall back on manually managed projects. So that's what project generation is all about. Fantastic. You're convinced project generation is for you. What options do you have out there? And I'll cover a few. First, I'll go through some low-level libraries and then some high-level tools. And the reason I want to bring up low-level libraries is maybe you want to test the waters. Maybe you're not ready for full-on project generation, but maybe you just want to test some automations in your workflow. And this is where low-level libraries are useful. As we discovered earlier, PBX proj files are nothing more than property lists, and Foundation has native support for reading property list files. So you don't need any third parties. You can use either of these classes, property list serialization or property list decoder. In this example that I will go to next, I'll use property list serialization. It's a little bit easier to use, especially if you're not quite sure what format you're going to get. So the snippet of code simply gets a dictionary from the PBX proj file and prints it out. And if you do this, you will see something that looks very familiar to what we saw earlier in the talk, the PBX proj file. And here you'll see it's not very readable, but you can parse through it, like you can use it. You'll see these IDs like FB379, blah, blah, blah. And these actually will map to different files, different elements, and you'll need to build your own lookup tables to say what this ID actually refers to. It could be quite cumbersome. Luckily, others have done the hard work for us and have published some awesome libraries. The first one that I'll cover is called Xcode Proj, the Ruby gem Xcode Proj, which powers CocoaPods. And it gives you a very nice semantic API around your project files. So here in this example, we're just iterating through all the targets in the project and printing it out. However, if you're more Swift inclined, there's a similarly named project or Swift package called Xcode Proj as well under the toist.org, which allows you to do the same thing. These are simple examples. You might be wondering, how is this going to be any useful? I'll give you another final example in the low-level libraries domain here. Say, for example, you wanted to print out all of the projects that have an outdated version of Swift. In fact, I had to do this the other week because we were quite curious how many projects we needed to migrate over to using Swift 5 that were still using older versions of Swift. So this little snippet of code will iterate through all the project paths I give it, and it will tell me which targets are still using an outdated version of Swift. So you can see how you can introduce little utilities and helpers just to help your day-to-day automation, even if you don't do project generation. All right, now high-level tools. I'll cover 4 of them. First one is CocoaPods. It's probably the most popular one out there to date. And if you use it, I'd recommend use it with CocoaPods Generate, and I'll explain why in a bit. It's written in Ruby. Its definition file is known as a Podfile or a Podspec. It's also written in Ruby. This is a Podfile. Typically, you'll have one for your main application where you declare what it is and what you depend on. This could be third-party libraries or even your own local libraries. And in CocoaPod speak, a library is simply known as a pod. And for every pod, you need a Podspec, which we will see. So let's take, for example, the pod authentication, which lives on this local path for me. And the Podspec for authentication looks a little bit like this. And as we saw in the earlier examples, here's where you define, like source files are in authentication classes, take all the source files there. Perhaps the authentication assets, they're under the assets folder, so on and so forth. And you can also specify what this pod depends on, or this library depends on. You'll notice there's quite a bit of boilerplate here at the top part, especially if you never ever plan on publishing this pod. Say it's just an internal library and you're only using CocoaPods to help you manage your internal dependencies. This could be quite cumbersome, but luckily this is Ruby, so you can write some helper functions, some helper methods to help you reduce the clutter. And additionally, because it's a programming language, you can write or define what a module means to you. It could mean like the module name plus a module name test, so authentication plus authentication tests plus authentication mocks. You can kind of code in your own conventions to it. And to give you an overview of like what you get out of CocoaPods, you'd have your main application at the top level. That's where you'd put your Podfile, and then you would have a Podspec per library that you have. And then when CocoaPod does its magic, it creates a parallel universe, so to speak, where it puts all its generated content. It would have a pods project, and more recently, it can also support multiple projects, so it might be more than one project here as well. And notice one thing. With CocoaPods, unfortunately, you cannot generate the main applications. It can only deal with all of your pod specs and generate stuff for it. And this is where the supplementary library, the CocoaPods generate by Square, comes in handy, because it allows you to generate an individual workspace and project for each of these separately to work on. And that allows you to have a discardable workspace for these individual libraries. But still, the downside is you have to manually manage your main application. All right, next up we have Swift Package Manager, and I'm really happy to see this on my list of options, because when I was preparing this a while ago, this wasn't even here. So I'm really excited that as of Xcode 11, this is now a possibility. It's written in Swift, and the definition files for it, known as package manifests, they're also written in Swift. And this is what a workspace with Swift packages looks like. In this example, I have all of these as local packages. And this is a package.swift file. You define its name, the dependencies it has, and where they live. So for example, here, the dependencies of feature C are common, design system, and networking. And this is where they live on disk. And the cool thing is, with Xcode 11, you don't need to actually generate projects for these at all. Xcode is happy to just open them up without any project, and that's the best form of project generation, the one you don't even need. And in this workspace, you'll have all of them there alongside your main application. This is what your workspace would look like on file system. You would have your main application as well as your individual packages where they have a package.swift each. The caveat or the downsides is you still need to manually manage that main application. You still need to maintain it yourself. You cannot generate it yet. I'm hoping there'll be a better story around this in a year or so. Another caveat is at this time, unfortunately, Swift Package Manager doesn't support any resources or shared settings, which could be a big blocker for anyone with an existing project, because there will be resources. You will probably have xtconfig files that configure shared build settings across all of your workspace. And lastly, as of now, I don't believe it supports custom build configurations. So as in our story from earlier, you cannot have a beta configuration with Swift Package Manager. If someone knows how to get that working, please let me know. All right, and then we'll move on to Xcode Gen. It's a Swift package written in Swift. It uses its definition files are known as project specs. It's written in either YAML or JSON. YAML seems to be the more popular form. And this is what a project spec looks like in YAML. You define your project, you specify what it is. It's an application, where the sources live, and what dependencies it has. So in here, it depends on a target called authentication, and this is authentication. It's a framework, it's for iOS, and this is where the sources live. And this simple example will generate the main application, which is fantastic. It can generate pretty much most things for you. And this is what a workspace would look like with it. You would have your project.yaml for your root. It also supports including other YAML files, so that you don't have a monolithic manifest, so you can split out the different target definitions into separate YAML files. Unfortunately, though, it can only generate a single project. It cannot generate a workspace with multiple projects for you. So at the end of the day, you will get one monolithic generated application with several targets. You can probably make it work to generate a workspace and projects if you write some tooling on top of it. But it doesn't give that to you out of the box, sadly. The last one I'll talk about today is called Twist. It's written in Swift. The definition file for it is known as a project manifest. It's heavily inspired by Swift Package Manager, and as such has also been written in Swift. This is what your project manifest might look like. You can define your application. Same thing, sources, what it depends on. It depends on a target called authentication. This is the definition of the target, so on and so forth. And the cool thing about Twist is it does support workspaces. So instead of defining all of your targets here in one file, you can separate out the authentication project manifest into its own one and reference it as such. And Twist will generate a separate project for it. So this is what a workspace with Toist would look like. You could have a project.swift for each of your modules or targets, including the top-level application. So it will generate the top-level application. It will generate all of your modules, and also it will generate a workspace to include all of them for you. So this is quite powerful. All right. You probably heard me talk about all these tools, and you're wondering which one should you use. Unfortunately, none of these tools, I'd say, are 100% perfect. None of them are going to be the silver bullet for you to use, but the beauty is you can mix and match. As we saw with CocoaPods and SwiftPM, they can handle local and third-party dependencies, which I didn't mention, but Xcode and Toist don't do. That's not their main focus. So what you can do is you can use either of them to generate the top-level application, and then use CocoaPods or SwiftPM to manage your external libraries, so you can mix and match to suit your needs. And it would be unfair to try and compare them as the same thing, because they're all trying to do different things. There's a little bit of overlap, but they're all trying to do slightly different things. And to help kind of illustrate this, I've drawn this little three sections. The first one is I'd call the dependency manager, but that's what both SwiftPM and CocoaPods do. They manage your dependencies, either external or local. Then you have the project generator circled, so to speak, and the only true dedicated project generator is really Xcode Gen, and this is why it does it so well, because it's dedicated to it. And however, all of the others kind of do project generation out to support the features they need. You'll notice here I put SwiftPM kind of on the border, because prior to Xcode 11, it was a necessity to generate projects to work in Xcode. You now don't need it, so it's not technically a project generator, but it did it. Whereas CocoaPods does need to generate projects, but more to support its feature set. And lastly, I have this category called Workspace Manager. I don't know if it's the right terminology for it, but what it does is help manage your local workspace for you. And this is what Toist and CocoaPods do. They will take care of the workspace for you. And this is, that's the area they take care of. And yeah, that's kind of a nice overlap of all of these tools. All right, you're probably wondering at this point, what did we do? What did we choose? And we ended up basically writing some internal tooling on top of Toist generator. We really liked the whole workspace workflow quite a lot, because it mimicked what we originally had. Because what we wanted to do is see, can we do something which make it transparent to our existing developers that something has changed, like that we've developed it. And we managed to get something that looks fairly similar to what we already had using Toist. So we decided to just write some internal tooling that takes our own manifests, like custom Project.swifts, and pre-process them to then use Toist generator, which is an internal library of Toist, to generate the entire workspace and projects. We're about 50%, just over 50% of the way through our migration process. I'll walk you through what that's looking like so far in a bit. But that's where we are. We're like just over 50% at this point, generating projects for our workspace on top of Toist. And you're probably wondering, why did we do it that way? Why didn't we just use Toist directly? And really, it's because we wanted the flexibility to swap what we use internally, because we're considering using an alternate build system, in not like we might do that in the next year or maybe the year after. We don't want to dismiss that option. It's just not good it's not a good fit for us today, but doesn't mean it won't be in the future. So if we have our own custom manifests that we pre-process, maybe we can generate something like a Buck or Bazel build file out of it. Or maybe if SwiftPM addresses all the shortcomings it has today, maybe we just generate package.swifts and delete the tool afterwards and call it a day. So it does give us that flexibility. All right, you're convinced project generation is for you. You've picked a tool. You have an idea of what you want to do, but you have an existing project. How do you go about migrating it over to be generated? And I'll have 3 tips for you. First one is work your way up. Try and draw out your project as a dependency graph, where you have the least most dependent, or the node that has no dependencies on one side. Take its project, and use whatever tool to convert it, or rather generate it, but keep it alongside and do a comparison. Check, do the sources match, do the headers match, do the build settings match? If you have unit tests for this, even better. Run the unit tests, make sure they pass. And once you're happy, replace it in the main workspace and move on. And here I say check it in because of something very important. At this point, you're still testing this out. You're not sure. Can you reach the top without any hiccups? Will there be any workflow issues? And if you check it in, no one will ever notice that something's changed, because what you get is a fully valid project that would look almost like you would have made it yourself. So that way you won't disrupt the existing workflow, and you can continue on climbing through your dependency graph. Next is automate comparisons. Chances are, as you go through your migration process, you're going to get to some bigger projects, like a whole-fledged feature, and they're going to be much bigger. They're going to have a lot more code, they're going to have a lot more settings, and it's going to get quite tedious and very error-prone to compare them manually yourself. But as we saw, there are some libraries that can allow you to read the project files, and you can pretty much write some tooling to let you do that, because you can read the first project, read the second project, and just do a diff. And you might be wondering, why do you need to write a tool? Can't you just do a git diff? And if you remember from earlier, the PBX project file, there's a lot of these IDs, and it's not very, every time you move files around, etc., these IDs might differ. And for example, the order might differ as well. As such, you cannot do an identity check. You have to do a semantic check. And we've had to do this quite a lot. In fact, we wrote a little tool called xcdiff to help us with this. You give it both projects, the original project, the generated project, and it will tell you if there's any differences between the different attributes. If there is, it will flag them out. It will mention, hey, in your second project, you have header 4, but it wasn't there in your first project. And this very fact was very interesting to us. We discovered a lot of dead code or dead files in our workspace that Xcode wasn't referencing, but they were still in our source code. And during this process, we've done a lot of cleanup as a result. Additionally, not only will it mention what's different, but it will also say, oh, the file does exist. However, it's slightly different public attribute. Like one of them is public, the header, and the other one is like not specified, which would mean a project visibility for a header file. If you're interested, you're more than welcome to give it a go. Give us some feedback. If you do encounter go on the same journey as us, we'd be more than happy to hear and help you out. All right, the last tip for today is add linting to your workflow. And why do you need linting? And what I mean here is you're happy going through the whole workspace, converting one project at a time, everything is all good, but maybe one of your colleagues who's just joined doesn't know about your efforts, about these whole, like you generating them, and does a small manual modification to one of the projects, which is fair enough. However, maybe they add a source file that isn't in your sources folder, which means if you regenerate this project at some point, it will be missing a file. And you don't want to regress, you don't want to have to repeat the process over and over, but what you can do is you can add some linting. And what that is just simply on your CI, every time you have a pull request, generate your project alongside the one that's checked in and run a comparison on it. So it's just a simple generate and then run something like xcdiff. And if there's any differences, fail your build and to flag out that there's a regression. All right, so that's pretty much it for today. Just some final takeaways. Xcode projects can be complicated. They're not magic. It really pays off to fully understand them, because it will help you decide what tool to use, to understand what they do. Actually, up till I dug into this, I was always afraid of CocoaPods. Like, what does it do to my workspace? And once I fully understood what project generation is and the Xcode project format, I've now a bit more comfortable. I see exactly what CocoaPods is doing, and I can tell if it's wrong or if it's fine. And then consider some automation, because you don't want to constantly have a massive document saying, don't forget to add something to your project file. And yeah, that's it. Here are some references which this talk was either inspired by, drew conclusions, or referenced, so they're very useful. And yeah, I'll just give it a moment. All right, thank you all.